Alright, 4-4 trig functions of any angle. So we're going to be using our special angles 30, 45, and 60, and then moving them into different quadrants, quadrants 2, 3, and 4 for this section. So let's take a look back again. We should know at this point that sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent, our SOHCAHTOA model. And if we have our unit circle, we know that R is our hypotenuse, and so in this case R is always going to equal 1. The hypotenuse is always going to be 1 if we're on the unit circle. Alright, and then if we have some angle in here, on the unit circle, if we look at this, the opposite side from this angle is always going to be the height, so it's going to be y. So in this case, in any time in the unit circle, opposite is going to be y, and adjacent, the side next to the angle, is going to be our x value. So x is your adjacent. Alright, so in this model, if we think about sine as opposite over hypotenuse, we can also think about it as y over r, or if we're on the unit circle, just y. Same thing with cosine. Cosine is going to be adjacent, or x, divided by the hypotenuse, which in this case is r, or 1. So the cosine is x. And this is true anywhere on the unit circle. It doesn't just have to be in quadrant 1. So if we look over here, we're in quadrant 2. Here's our angle. If we made a new triangle going straight down, make a right angle, the x is going to be the adjacent side, and the y is going to be the opposite side for that angle. It's the triangle that it makes. All right, so knowing that, let's flip over here and we'll say, okay, let negative 3, comma 4, so I'm going to plot that point, be a point on the terminal side of theta. What that means is our angle started here on the x-axis, and our angle, theta, swung over until it hit that point there, this line going out forever. All right, and the point negative 3, comma 4 is on that line. All right, so our job is to find the sine of theta, the cosine of theta, and the tangent of theta. All right, well, we know that sine is our y value divided by our r value. Now, if we were on the unit circle, r would just be 1, and that'd be really nice and easy. But we don't have the unit circle, so we're going to have to figure out r. So what we're going to need to do is make a nice right triangle. And I'm going to redraw it over here so we don't have any other lines messing us up. Our x value is negative 3, so sideways is negative 3. Our y value is 4, so up and down is 4. We have to figure out the hypotenuse. We could do this with the Pythagorean theorem, but I think at this point we should know the 3, 4, 5 right triangles. So the hypotenuse is going to be 5, and I got 5 with Pythagorean theorem. All right, we're ready to plug everything in. The sine is y over the hypotenuse, r. The cosine is x over the hypotenuse, r. So the cosine is negative 3 over 5. And the tangent is opposite, y, over adjacent, x. And so in this case we'll have 4 over negative 3, or negative 4/3. And those are our answers. So knowing that, let's see if you can do this on your own. See if you can do problem 9, A and B. Find all 6, sine, cosine, tangent, and cosecant, secant, and cotangent. All right, on A, I'm going to draw my triangle. Our y value is 3, our x is 4, which means our r value, the hypotenuse, is 5. All right, sine theta is opposite y over r, 3/5. I'm going to write these in just so we can see them. Cosine theta equals x over r, so 4/5. Tangent theta equals y over x. So in this case, our y is 3, our x is 4. Let's go ahead and do the reciprocals. The reciprocal of sine is cosecant of theta. All right, so that's the flip. It's r over y, so 5 over 3. The flip of cosine is called secant, so the secant theta is r over x, so 5 over 4. And the flip of tangent is called the cotangent, x over y, so 4 over 3. Those are your 6 values for A. All right, I'm going to go ahead and erase these. Pause it and write it down if you need them. But here we go. Let's go ahead and do B. All right, we've got our triangle here. And let me redraw it over here, actually, just so I have space to write out the numbers. Our x value is -8. Our y is 15. And so Pythagorean theorem, -8 squared plus 15 squared equals r squared. 64 plus 225 is going to be 289. And if you do the square root of 289, you get 17. So our r is 17. All right, now we have all 3 sides of the triangle. We're ready to plug in. The sine is 15 over 17, y over r. The cosine is -8 over 17, x over r. The tangent, 15 over 8, and it's a negative because the 8 was negative. The cosecant is the flip, so 17 over 15. The secant is the flip of cosine, so -17 over 8. And the cotangent is the flip of the tangent, so -8 over 15. All right, those are your answers for 9A and B. Let's move on to example 2. And so same type of thing, but now we need to know where on the unit circle we are. Not the unit circle, but just in the coordinate plane. Because they tell us a couple things. They tell us the tangent is -5 over 4. But remember that the tangent is y over x. So the question becomes, which one is negative? Is y negative? Or is x negative? Only one of them can be negative because we have a -5 over 4. It's either -5 for y or -4 for x. Well, the answer comes from this thing here. They tell us a clue. Cosine theta is greater than 0. Remember what we know about cosine. Cosine is x over r. R is a hypotenuse. R is always going to be positive. So if r is positive and the whole thing is positive, then x is positive, which means y is negative. So if we were to plot this, x is positive and y is negative. The only quadrant where that exists is down here in quadrant 4. So we're going to go ahead and find a point down here. And we know that our x is positive, so it must be 4 and -5. Remember that the y has to be the top and the x is the denominator if tangent theta equals -5 over 4. All right, so let's go ahead and draw ourselves a triangle. And so we've got a 4, we've got a -5, and so Pythagorean theorem, 25 plus 16 is 41, so our hypotenuse is the square root of 41. So we need to go ahead and find the sine from this angle. That's y. Remember, sine is y over r. -5 over root 41. Can't leave it like that. Let's multiply top and bottom by root 41, so we'll get -5 root 41 over 41. That's our answer for sine. And secant is the flip of cosine. Okay, so this is going to be r over x. For secant, r is root 41, x is 4, and we are done. Okay, all right, so see if you can use that information for problem 23. All right, tangent is y over x, and sine is greater than 0, so that's saying y over r is greater than 0. Seeing as r is always greater than 0, y has to be greater than 0. So y is positive, x must be the negative here. So that's over here in quadrant 2, where y is positive and x is negative. I'm going to draw myself a nice triangle, and let's label it. The x is 8, negative, and the y is 15. These numbers should look familiar. We did it recently in the recent problem. We're going to get r is 17 from the Pythagorean theorem. And so it wants all 6 of them. So let's knock them out. Sine is going to be 15 over 17. Cosine, negative 8 over 17. Tangent, negative 15 over 8. Flip of sine is cosecant, 17 over 15. Secant is the flip of cosine, negative 17 over 8. And the flip of tangent is cotangent, negative 8 over 15.